Welcome to my channel Born to Learn. Today we are going to learn about balancing of chemical equations. Balancing of chemical equations. To make equations more informative, the equation which gives more information about the chemical reaction is known as more informative or information giving equation. The chemical equations can be made more informative in three ways. 1. By indicating the physical states of the reactants and products. 2. By indicating the heat changes taking place in the reaction. 3. By indicating the conditions under which the reaction takes place. We will discuss these 3 points in detail one by one. 1. To indicate the physical states of reactants and products in an equation, there can be four physical states for the reactants and products of a chemical reaction: solid, liquid, aqueous solution, and gas. Solid state is indicated by the symbol S. Liquid state is indicated by the symbol L. Aqueous solution made in water is indicated by the symbol AQ. Gaseous state is indicated by the symbol G. The physical states of reactants and products are shown by putting the above state symbols just after their symbols or formulae in an equation. This will become more clear from the following example. Zinc metal reacts with dilute sulfuric acid to form zinc sulfate solution and hydrogen gas. This can be written as Zn plus H2SO4 gives as ZnSO4 plus H2. Here zinc metal is a solid, so we write Zn of S. Dilute sulfuric acid is an aqueous solution, so we write H2SO4 of AQ. Zinc sulfate is also an aqueous solution, so we write ZnSO4 of AQ. And hydrogen is a gas, which is written as H2 of G. The above equation can now be written as Zn of S plus H2SO4 of AQ gives as ZnSO4 of AQ plus H2 of G. This equation is more informative because it tells us physical states of various substances involved in it. It tells us the zinc is in the solid state, sulfuric acid is in the form of an aqueous solution, zinc sulfate is also an aqueous solution, but hydrogen is in gaseous state. In some cases, an insoluble product called precipitate is formed by the reaction between solutions of reactants or a solution and a gas. Since the insoluble product or precipitate is a solid substance, its physical state is indicated in the equation by the symbol S. 2. To indicate the heat changes in an equation, there are two types of reactions on the basis of heat changes involved: exothermic reactions and endothermic reactions. 1. Those reactions in which heat is evolved are known as exothermic reactions. For example, when carbon burns in oxygen to form carbon dioxide, a lot of heat is produced in this reaction. C of S plus O2 of G gives as CO2 of G plus heat. Carbon plus oxygen gives as carbon dioxide plus heat. The burning of carbon in oxygen is an exothermic reaction because heat is evolved in this reaction. An exothermic reaction is indicated by writing plus heat or plus heat energy or just plus energy on the product side of an equation. So, whenever we are told that a particular reaction is an exothermic reaction, we should at once write plus heat or plus heat energy or just plus energy on the right side of an equation. The burning of natural gas is an exothermic reaction because heat is produced in this reaction. Please note that all the combustion reactions are exothermic reactions. The respiration is an exothermic process because energy is produced during this process. 2. Those reactions in which heat is absorbed are known as endothermic reactions. For example, when nitrogen and oxygen are heated into a very high temperature of about 3000 degrees Celsius, they combine to form nitrogen monoxide and a lot of heat is absorbed in this reaction. N2 of G plus O2 of G plus heat gives us 2NO2 of G. Nitrogen plus oxygen plus heat gives us nitrogen monoxide. The reaction between nitrogen and oxygen to form nitrogen monoxide is an endothermic reaction because heat is absorbed in this reaction. An endothermic reaction is usually indicated by writing plus heat or plus heat energy or just plus energy on the reactant side of an equation. The reaction in which nitrogen and oxygen of air combine to form nitrogen monoxide takes place inside the engines of motor vehicles. All the decomposition reactions are endothermic reactions. Third one, to indicate the conditions under which the reaction takes place. If the heat is required for a reaction to take place, then the heat sign delta is put over the arrow of the equation. If the reaction takes place in the presence of a catalyst, then the symbol or formula of the catalyst is also written above or below the arrow sign in the equation. This will become more clear from the following example. When potassium chlorate KClO3 is heated in the presence of manganese dioxide catalyst, it decomposes to form potassium chloride and oxygen gas. This can be written as 2KClO3 of S gives us 2KCl of S plus 3O2 of G. Potassium chloride gives us potassium chloride plus oxygen. Here delta stands for heat and MnO2 is the catalyst. So the above equation shows the conditions under the which the reaction takes place. The conditions of temperature and pressure at which the reactions takes place can also be indicated in a equation by writing their values above or below the arrow sign in the equation. That's all for today.